Okay, so this is an interesting question. It's talking about how many different three-digit numbers can we use, and we can only use those digits once. And so it's nice to have a little picture, right? Now, of course, we can't put that 0 here because three-digit numbers don't start with 0, okay? So we can put any one of these guys, right, in that first position, okay? So what we're going to do, we're going to count the number of different digits we can put in that first position. And you can see there's going to be, if we just try and think about highlighting them, isn't there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 that can go in there, 9 different digits. Now, of course, when I put this 9 here, I don't mean that 9 goes there. I just mean there's 9 different digits that can go here, all right? So it's important that we understand that the numbers here represents the different digits that can go in those positions, all right? So now we've used one of the digits. You've got to think about, well, how many digits have I got left? So for instance, I've used one of the digits. Let's say I did use that number 9. Well, can you see that I've got all of these digits left that I can use in the second space? And you can clearly see that there are still 1, 2, 3, 4, 5, 6, 7, 8, 9 digits, all right? So I can use any one of the 9 digits in here. But again, once I've used another digit, and it could be the 0 right this time, the 0 could go second. Once I've used a second digit, can you see what's left? There's 1, 2, 3, 4, 5, 6, 7, 8 digits left, okay? So there's the answer to the first one. It's 9 times 9 times 8, and I believe that is 648. So 648. Okay, part B now. Well, we do actually have to fix B. It says end in 5, so we can actually move that digit there and stick it in here. There's only one way to fill that last slot, all right? So I'm going to put another box here. There's only one way of filling that last slot, right? It has to be the digit 5. But of course, you realise that then the first digit we can't have this. We can't have the 0 starting. So there you can see how many digits we've got for the first position: 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 different digits that can go in here. Now let's think about it carefully. Once we've used one digit here and we've used the 5 here, that's 2 digits down, right? So 2 digits down from the 10, there's only 8 remaining. Therefore, we can choose from any one of the 8 remaining here. So that's 8 times 8 equals 64. Part C, similar thing. It has to end in 0. Let's go put a 5 back up here now. Now, this guy has to end in 0. So let's grab this and put the 0 here. All right. And now you can see that there's 9 digits here. And of course, any one of the 9 now can fit in that first position because the 0's been accounted for. So there's definitely 9 ways of filling this first one. And then if we've used one digit here, and we've used the 0 there, we've used 2 digits, therefore there's 8 digits left. 9 times 8 is 72, and there's only one way of filling this last one here, so that's 72. And finally, part D asks for how many 3-digit numbers are divisible by 5. Well, of course, divisible by 5 means that it ends in 5 or it ends in 0. So the total number of 3-digit numbers is 64 plus 72. It's basically your answer to B plus C. And that is 136. Hope that helps. I think it certainly helps to visualize, numbers on cards and realize that when we kind of write this 9 here, we don't mean it's that 9 there. We mean it's 9 different digits available to go in that slot. If we do want to put a specific digit in a slot, then it's maybe nice to put it on a card like that, right? So I'm distinguishing the 0 and the 5 as physical digits put in there, and then these numbers here are the total amount of digits available in each of these positions. So I think that helps with the notation.